everyone, welcome back. This is the part 3 of Python DSA problem solving, and today we are going to start with all the recursion problems. So let's start. So print 1 to n without loop. Okay, got it. So print numbers from 1 to n without the help of loops. You only need to complete the function print numbers that takes n as a parameter and prints the number from 1 to n recursively. Okay, so n is something that we will take. Basically, recursion means there will be a base condition. And n, since n can be anything, uh, basically we will have the base condition something like if n equals to 0, then return not 0. If n equals to 1, then return. Because that's the base number. This will never change. The end limit can change anytime. It can be 10, it can be 9, it can be 100 or 1000. What's the limit? 1000. Okay, not that much. Yeah, because see, since we have to print the numbers in a loop and recursion is not really that optimized in terms of time complexity, it takes 2 to the power n big O notation. So that's why it's not optimized in terms of time complexity. So we have to make sure whatever functions we are doing, those are limited within a limited range, basically. That's why I think usually, although it's these ranges are around 10,000 or a lakh or around 10 lakh or a million per se, but right now it's about 1,000 because that only will take the time complexity to a different level. So right now what I think we will do, let's write the base condition first, right? So the base condition would be something like if n equals to 1, then print 1. We have to print, right? And then let's say return. And we will return to where the function is called next. And we will first do print numbers and n minus 1. Right, so basically how it will progress is first, let's say n equals to 10. If n equals to 1 will not satisfy, so this won't be executed. After that, immediately it becomes print numbers n minus 1. And so on and so forth. This will go on in loop until and unless your n is becoming 1. Then 1 will be printed and then finally all the calls will be returned. So whatever calls, function call were stored in stack, it will start popping one after another. So starting with 1, then let's say immediately next if I give print n, then it will start printing 2, 3, 4, 5, 6, 7 until it will go to 10 and yep, that's it. That's what will happen. Yeah, okay. I think that is it. Print numbers n minus 1 was 9 and when 9 will be returned, finally 10 will be printed. Yep. Okay. Let's try this. Self print numbers. Yeah. Sorry, this is within the same class, so we have to, refer to the instance using self. Okay, got it. So there's a method in Python where we want to just end the new line character where we will use this end parameter and use a blank string within quotation. This is something that you have to kind of memorize. So, yep, okay, cool. Let's submit and check. Okay, test case is passed. Let's move on to the next question then. Print name n times using recursion. Okay. Print GFG n times without the loop. Okay, print GFG. If it's 5, then we will write 5. Pretty similar to the previous problem, no? So let's say if n equals to 1, then we will print GFG. And I think again we'll have to give this n equals to space and then return, right? What's happening? Okay. return, and then if not, then I would again do print GFG. GFG is nothing but geeks for geeks. Print GFG, and I won't be sending it. No, I would be. Okay, n minus 1, right? Okay, I would have to do self.print GFG n minus 1, and then I will do print, right? GFG. Exact same thing. Yeah, basically, so here print GFG will start from n equals to 1 and go till n equals to n. But if we do it the other way around as well, so it starts from 5, let's say, and then goes till 1, that's also is fine. Anyway, try this. I think either way will run. Let's check. Okay, submit. Okay, yep, this is cool. Moving to the next question. Okay, before that, just to show you, I think we can do it this way as well. So I'm printing first and then I'm calling the function. So first what will happen when, let's say n equals to 5, first GFG will print, then it will call 4, again GFG will print, again it will call 3, again GFG will print 2, 1, after that GFG will print return, and every call will be returned subsequently, and then, yep, will be ending loop, recursion loop there. I think this also should be printing fine. Either 10 to 1 or 1 to 10. Yep, it is. Cool. Okay. Let's move on to the next question. Print numbers from 1 to n again without the help of loops. Isn't it the same question? Yeah, I believe so. It's the same question, right? We just solved this. Understanding recursion. Okay. So basically they have given same questions under two different names, but these are essentially the same question. Anyway, can't do anything about it. Let's move on to the next one. Print n to 1 without the help of loops. Okay, I think we just discussed this, right? So if n equals to 1, then, sorry, we can just actually copy this. A little shortcut. When equals to 1, print 1, return, and self print numbers. No, we have to print it first. Right? So logically what will happen? First 10 will print, then 9, then 8, and then finally 1, and then all the calls will be returned and the program will end automatically. So let's start. Indentation error. Okay, indentation error. Okay. Okay. Cool. Okay. All test cases passed. These are, I think, slightly easier problems only, just to make our concepts of recursion clear. Now coming to the next problem. Okay. Sum of first n terms. Given an integer n, calculate the sum of series 1 cube till n cube. Okay. So if n equals to 5, 1 cube plus 2 cube till 5 cube. Excuse me. Input n equals to 7, then 1 cube through 7 cube is the number. The summation is what we want. 1 less than equals to n less than equals to 200. Okay, so n is less than 200, which makes total sense because otherwise runtime error aata rahega, right? So this makes total sense because, so constraint wise, n is line between 1 to 200, and this makes total sense because otherwise a runtime error ही आता रहेगा, right? Okay, so let's move ahead. So you have 1 cube to 7 cube. I'll pretty much do the same thing. Only thing is we'll have to continuously keep this count in some basically in a separate variable. So what will we do? We will do basically for I in range. Let's take sum equals to 0 here for I in range of 1 through n plus 1, right? Then we will just keep on taking sum plus equals to I to the power 3, and then we will return sum, right? But I think since this is part of recursion, some of us n numbers, probably they wanted this solution using recursion itself. Let's run this and think about how we can solve this in recursion as well. Okay, for I in range this, and yeah, I think this is fine. 125. How and why? Sum equals to 0. I was 1, 2, 3, 4, 5. Okay, what if I do this? Some series where I don't think that's a problem. But anyway, so since sum is a function, I'm just changing the variable name to something else. Your output is 125. 125 means it's 5 cube. So 1, 2, 3, 4 would become somewhere like 1 and 8, 9 plus 27, 36, 36 plus 64. That's 100. Yep. No, but that's not coming. Plus equals to I to the power 3, right? I in range 1 to n plus 1. Sum series equals to, oh, equals to plus, sorry. Plus equals to. Sorry, my bad. Yep. This also should be running fine, yes, but just wanted to understand if this can be solved using recursion as well. Yeah, okay. So I'm thinking probably this is something similar to, let's say, Fibonacci, where we used to return n minus 1 plus n minus 2. So what we can do, maybe we can do n plus n minus 1. So write the base condition still, if n equals to 1, then return 1. Otherwise, you can call. Okay, so base condition would be this: if n equals to 1, then return 1. Otherwise, what we will do, we will return, let's say, n multiplied, n cube plus self dot sum or series n minus 1. Yeah, how about this? So first this is, let's say, 5 cube, then again this is called, then 4 cube, then 3 cube, 2 cube, 1 will return 1, and everything else is already there. So sorry. So basically 1. Then again 2 will unfold, 3 will unfold, 4 and 5. At the end, I think we will have everything that we need. Let's see. Yep, okay. Cool, okay. So this is correct. Let's move on to the next question. Okay, so the next question is factorials less than or equal to n. A number n is called a factorial number if it is the factorial of a positive integer. Yeah, that makes sense. The first few factorial numbers are 1, 2, 6, 24. Yes. Given a number n, the task is to return the list of a factorial numbers smaller than or equal to n. Okay. I think that makes sense. Okay, let's try doing this using maybe a loop first, and then we will do it based on recursion. Okay, so let's try this. How about, since we have to return a list, that means we have to take a list separately. So let's identify this as, let's say, 1 into a list of ones of n plus 1, right? So starting from 1, mm, so 1 would be 1, sorry, 0 would be 1, 1 would be 1, 2 would be something like that. So even the 0th index would represent 1. Yeah, that is also fine, right? Because factorial of 0 is 1 itself. So that makes total sense. Now let's go on to start the loop. So for I in range, let's say 1 through n plus 1, right? And then what will we do? We will take, let's take a variable. What if we take something like factorial? Okay, so factorial can be 1, yes, because this is a multiplication, you have to take 1, cannot initiate it to 0. So factorial would be multiply equals to I, right? So we have to continuously multiply the factorial number with I, and then what we can do, let's append this L dot append with factorial, right? So first it'll append 1, then it'll append 2, then it'll append 6, something like that. So L dot append factorial, yes, that makes sense. And then we have to break it. So let's say anytime the factorial is greater than n, if factorial, oh, we cannot do that. One second. So let's say factorial is greater than n, let's reverse that, then only this loop will break, right? And oh, okay, this has to come up first itself. So first we will append, let's say if factorial is indeed greater than n, that means we'll have to return the list till before I, basically. Okay, so we will be returning list of 1 through I because we have to start from 1. That's it, because the numbers will start from 1. And then I think one thing we need to change here, we are not appending, but rather we are replacing, right? So we are replacing L of I equals to factorial, right? And then if factorial is greater than n, then we will break and we will return list of 1 through I. Let's do a quick dry run. Let's say if the input is 6, then we are taking a list of 7 elements, and then we have factorial to be n. For I in range of 1 through 8, factorial is multiplied by I would be 1, 2, 3, and subsequently all the other numbers. Then L of 1 will become factorial, that is 1. L of 2 will become 1 into 2. L of 3 will become 1 into 2 into 3, things like that. And then if factorial, let's say 6 is greater than 6, the number, then it'll break. Then it will break, right? And then it'll come here and then it'll return till 1 through I. And I, let's say for 6, what will it be? We will see that L of 3 only is becoming 6 and 6 is not greater than 6. So it will again run for another iteration of the loop, and L of 4 will become 24, and 24 is definitely greater than n. So that time it will break, and we will take data from 1 through 4. And since list indexing or list slicing do not get you data till the end index, so I won't return any result, and rather we will be getting the result till I minus 1 index. So basically we will be getting 1, 2, 6, which represents the index of 1, 2, and 3. Hopefully this is easy enough. Let's just run the result right now. Okay, 3, it's 1, 2, expected is 1, 2. Okay, let's try out. Request queued, runtime error, time limit exceeded. Expected time limit is 1.01. Please optimize your code. Okay, but it's taking n only, no? So how I am thinking of optimizing is, let's just create an empty list rather than, going ahead and creating a list of ones, and especially given that the range of n can actually go till 10 to the power 18, which is massive. So let's just stick to an empty list, I think. Okay, so let's try and run. Okay, this is still runtime error. My output is nothing. Li equals to factorial list assignment, index out of range. Okay, index is out of range. Index is out of range. Why? L is an empty list, right? Oh, sorry. I have to append for this. Yeah. What just happened? Okay, let's compile. Case 1, n is 3, your output is 2 and 6. Expected output is 1 and 2. Okay, so let's try it on. So 3, okay. 3 means n equals to 3, n plus 1 is 4. Factorial is 1. Star equals to I. That means it's again multiplied by 1. L dot append factorial, that's 1. If factorial greater than n, 1 greater than n, no. Again going back. So it's 2 now. Factorial into 2. So L dot append is 2. Okay. 1 and 2. Why is it 2 and 6? For I in range 1 through 1. 1 through n minus 1. Yeah. L dot append. I'm not using Li, right? I'm using L dot append. Okay. Can I print L just to check? Why is it printing 2? Your output 1, 2, 1 to 6. Okay, great. Then why is it 2, 6? Oh, sorry. But 6 is not needed. So why is it 6? So if it's 3, so let's say I is 3 and factorial is multiplied by 3, L dot append this. If factorial is greater than n, then break. So 3 is greater than 6. 3 is greater than 3? No. We need to give an equals to here. Then it breaks and then it comes here. Then L of 0 to 3. 0 is 1. 1 is 2. Okay, and then this is appended as well. So it's 1, 2, and 6 per se. So we don't need that. Okay, let's bring this up, right? And then we append. So if factorial is greater than n equals to n, 3 is greater than equals to n, sorry, 6 is greater than equals to n, then we'll just go ahead. We won't append, we'll just break out and then return till I. So since it's not getting appended, so it will return till L of I would be, I is 3 here, right? So 3 would be, so 0, 1, 2. 0, 1, 2 will be returned. 0 is just return L, no? I'm not appending. It's just return L, list, everything. How about that? Expected output is also 1 and 2, but it's very, can I return something like this? L, list directly. No slicing required because I'm returning the whole list. This is taking a lot of time, so I'm very sure in submit it will probably throw me a runtime error for a larger n. Okay, 0 out of 159. That's bad. Your input for input 1, code's output is 0. Correct output is 1. Okay, if it's 1, factorial is greater than n. 1 is greater than n? No, then L dot append. Let's try this. I think this is better. Okay, it's taking a lot of time. This is passed. So let's submit. Probably the first test case should pass for one. What about others? Oh my God. I'm very happy. Okay, so yeah, this was a very simple problem actually, but I think the way I started with taking a list of ones, that was the main issue. So we can always start with an empty list. I think that's better. This is not a DP, this is not a limited size array or list altogether. So definitely empty list makes more sense. All right, so let's move on to the next question. All right. So reverse an array. You are given an array of integer ARR. Your task is to reverse the given array. Modify the array in place. Okay. In place means we have to replace the array with the new reversed array. So input is 1 for this and then we have to return this. Okay. So what we can do, can't we just swap the places? So let's say for I in range 0 comma length of r, right? Then what will we do? We will just take r of 0, oh sorry, r of I. We can do a like swap here. So basically, let's say what we can do without taking a separate variable. So swapping a variable, we can always do taking a third variable into account. But let's say if we don't want to do that, either we can then in that case, we can either implement a multiplication and division method or we can use a plus minus method. I think the plus minus one is much easier because that doesn't, in division it can actually change your number into some other float or some other rounded off integer altogether. So let's not go there. I would always suggest let's do the swapping using, let's say, plus minus. So just to show you how what we will do here, so let's take this example 1 4, right? So if I do a right, so that this is the case. So now what will we have to do? We'll have to do first, let's say this is R0. So we will do what? We will take R of 0 equals to R of 0 minus R of n minus 0, right? Which is basically nothing but n is length of I. So, sorry, length of r, and length of r is 6. So, 6 minus 0 is 6. That is out of range. I think n minus 1 minus 0 is what we will have to do in this case, right? So, in this case, this value will become, so r of 0 now becomes what? Now becomes, after this step, r of 0 becomes 1 minus 5, that's minus 4. So, and in the next step, immediately what will we do? We will do r of n minus 1 minus 0 equals to, so what do we want? We want this minus 4 plus 5 to be 1, right? So, this will be r0 is now minus 4, and then we will do r of n minus 1 minus 0. There you go. So, right now r of n minus 1 minus 0, it was 5. Now this became 1. And now in this particular step, again we will take r of 0, or basically r of I in the loop. we will take again 1 minus minus 4. So we will take r of n minus 1 minus 0, and then we will do r of 0, right? Great. Then we have this here, and then we have one here. That's it. That's all we need. We need these 3 lines of code. So let's go back. So here we will do for I in range this. So r I becomes r I minus, or what we can do, I think that will be helpful. We can just take length of r separately within the function. So we can just refer to that later. So now this is the case. Now I will do n minus 1 minus 0, or I, and then r of n minus 1 minus I would become r of I plus the same, r of n minus I minus 1. And r of I will again become what? This one, r of n minus 1 minus I minus r of I. Right? So this is how the calculation will go ahead for I in range this 0 to n. Or so when will it stop? It will stop after this has closed. So basically I is greater than n minus I minus 1. So let's do this. I think we have to use while loop here. So while I is actually greater than n minus I minus 1. That means I has crossed this line and n minus I minus 1 has come here. That means we have already swapped everything. So we are good. I less than this, or less than equals to this. Less than this is fine, I think. Then we are returning the r. Right? So that's it. That's what we need to do, I think. So let's compile and check. Oh ho ho, we have to give I plus equals to 1. Because it's while loop, we have to 4, 3, 2, 1. This makes sense. Let's go and check. Perfect. Okay, great. So we are done with this. Again, I'm telling one thing, in case you do not need to use recursion, don't use it, because these are, if you can see, right, this is not even taking full n. So, but anyway, this is going linearly. We can take big O of n as time complexity only. But even then, this is much faster compared to recursion. Although, what I think is, I have found a solution of how to do this in recursion. I'll just show you guys this. Bear with me. I'm not doing this in this particular platform because I need to pass another value, which is essentially I, because when you see we are replacing the starting index with the end index and kind of swapping the characters or elements in between. So we would definitely need to pass one index for r, which is not there currently with this setup of the function in GFG platform. So I will be doing that in the Jupyter notebook. So here we are in Jupyter Notebook. So we will just follow the same structure. So let's just do reverse an array and let's create a function. Let's call it reverse array, right? And then we are providing r as one parameter, and then we are providing the index also as another parameter. And this parameter, what I'll do instead, I'll provide a argument or value to that as well. So I will start from 0 and then it will go on to increasing it one by one. Right? So these are called keyword arguments, and that's what I am putting it within the function call itself. So in reverse r, what I'll do essentially at the end, I will call this function, right? So I will call this function with, let's say, a list in mind. So L would be this, something like this. And then let's say I'm defining L as 1 through 10. And then what I'm expecting, the reverse array will essentially give me 10 to 1, right? So what I'll do here, Essentially the same concept, only in case of recursion, as you guys remember, we need to provide a base condition, right? So base condition would be, let's say if r equals to or length of r equals to 1 and return r. That's it. And let's say if it is empty, then also return the empty list, right? R 1 or 0 or less than equals to 1. So the base condition is done. Now let us write the swipe technique altogether. So we will just swipe this, right? So we will go ahead. We do not, since this is recursion, we do not need a for loop. We can just do it right away. And specifically with Python, we can just swap the elements then and there in the place. Why and how? So let's say r of I, comma, r of n minus I minus 1, right? So that would just become the opposite. So I will have these two. Right, so basically what I'm doing, r I would be replaced by r of n minus I minus 1 and r of n minus I minus 1 would be swapped by r of I. So that is something that we have added advantage in Python. I don't think it is available in C++ and all the other core coding languages, but anyway, since we are doing it in Python, we are definitely going to take this method in our advantage. So let's move ahead, and then what I'll do, I'll just call the function again since this is recursion, and then probably I'll return reverse array of r comma I equals to I plus 1. Right, that's what this is. So how will it function? So this is the base condition. If length of r is less than equals to 1, then this of, okay, sorry, my bad, there's nothing called n here, so it will be length of r. Okay, so length of r, if it is less than equals to 1, it'll just return the array directly, no other processing needed there. After that, r of I and r of length of r minus I minus 1, both of these characters will be replaced or swapped with each other. After that, again, we will just go up the index by 1, like we used to do in loop as well. So I equals to I plus 1, and then we'll again pass the array, right? Specific thing about changing the keyword arguments within the function call is that once you are creating a new argument, this I equals to 0 will be changed with I plus 1, the new value. So with every function call iteration, there will be new local variable arguments that will be passed and that will be used within the function call. I is less than n minus I minus 1, then only we will do the swap. Otherwise, we won't. So if I is less than n minus, length of r minus I minus 1, then only this swap will happen. Otherwise, they will just return it. So basically what's happening, once this condition is safely passing, then we are swapping as well as we are calling the function again. So recursion call is happening. This is going here. After the recursion call is stopped, so let's say I is no longer less than length of arr I minus 1, then the return calls will start on coming back. So the stack values will keep on popping, and after that there is nothing to return here. After that, automatically we'll just return the array, and that's it. That's all we have. All right, so coming to the next question. Check if a string is palindrome or not. Okay, this is a lit code problem. Valid palindrome. Python, okay. A phrase is a palindrome if after converting all the uppercase to lowercase, removing all non-alphanumeric characters, it reads the same forward and backward. Okay. So we have to strip off the spaces, we have to strip off the special characters, etc. So let's write one condition here. So if, let's say length of str is less than equals to 1, then return true, right? Else, only if this is greater than 1, then only we'll proceed with the next part. So next part would be I'm just importing one module here because I think to substitute all the alphanumeric keys or kind of strip it off alphanumeric keys, we would be needing regular expression anyway. Regular expressions are extremely handy. This is an extremely handy package to know about any string manipulation methods. So I would go ahead and use this. So let's say if I am substituting here, so what I'll be substituting? I'll be substituting all the non-alphanumeric keys, right? So non-alphanumeric keys would be anything which are not following under integers and characters, alphabets. That's it. So that after that, we'll go ahead and we'll replace those by space, and then we will pass the main string, which is s. That's it. You have a new s ready, and then you will check if s equals to s dot, or s dot lower, I think s dot lower equals to s dot. So this is a method. So colon -1. So this will actually give you the string reversed in a Pythonic way. What it does, so this colon is nothing but helps you in list slicing, or let's say string slicing. So you have to provide the index names. Here, if you provide two colons, which is basically you are done with the first and last index, and then after that you are just telling the string to reverse the particular string and start from the last index and go back one step each time. So -1 is nothing but the iterator here. So hope that's clear. Then we will just match these two. If in case these are matching, then we will return true, else we will return false. Right? Let's run and check. Object of type has no length. Um, import re. Oh, not str. Sorry, this is s. str is the data type. Accepted. Great. Let's submit and check. Not so great. How can we optimize? Can we just return this? So if it's true, automatically it'll return true, and if it's false, it'll automatically return false. S is fine, I think we're just replacing. Otherwise, we'll have to replace all of this into this line. I think this just looks bad. Let's just go ahead and run this and submit. No, not so great. Okay, let's check. So basically, we did exactly the same thing, but even then, our code is beating only 5%. So again, I'm saying do not pay any heed to all these, platform level ranking systems. I have no idea how they are ranking these codes. All right, so no issues. Let's just go ahead and finish our last problem of today, which is Fibonacci number. So Fibonacci is fn-1, fn-2. Yes, that's true. So we will just include n which is int, and then we have to return, calculate fn. So if it's 2, we have to give 1 because it's starting from 0, 1, 1. If it's 3, we have to give 2, and so on and so forth. Okay, fine. So if, let's say, if n equals to 0, then return 0. If elif n equals to 1, then return 1. Right? That's what it is. Else, we will do return fib of n-1 plus fib of n-2. Right? So I think that's what we have to do. This is pretty simple in terms of recursion. So n-1 would keep on going till 0, let's say, and n-1 will keep on going till n equals to 1, and n-2 will go till 0, and then it will automatically have the reverse callbacks and then give us the final result. Let's run and check. Okay, there's an issue. Invalid syntax. Elif n equals to 1. Name fib. But fib is defined, right? Fib is not defined, but fib is defined, right? Oh, okay. I think it's self.fib. Okay. Submit, please. Yep, we are good. And I think this is an absolute fine code. So you should not worry about any ranking. All right, so that was it for today. We actually solved a lot of recursion functions or recursion based problems which are there in this list. So recursion is especially important for you to understand the concept of stack calls and how all the recursion calls are getting listed in stack, and then one by one it's getting popped when it's reversed. So definitely recursion is one of the main concepts to step into DSA architecture of the whole DSA system of problem solving. So definitely this was a very good session according to me. Although let's say for some of the problem, if you think the problems can be solved easily using some loop or just one iteration of the string or the list, then I would ask you to do that without using recursion, because necessarily recursion does not take a lot of, let's say, lesser time complexity, but it's actually much higher in terms of time complexity. But in terms of code writing, recursion takes much less space and it looks a lot neat. And also, and as I mentioned earlier, the stacking concept of recursion calls are really, really important for us to do. So that was it for today, and we will meet you in the next one. Take care.